So imagine yourself come across a question like this in a test today, which is this thing, it's an analytical geometry. And this kind of question, guys, this one, they are kind of tricky there, whereby they need you to calculate a size of theta, calculate the area. Yeah. Last question, by the way, they usually become difficult. Take note about that. So here you are given that statement and you are told that OPQ is perpendicular to QR. Meaning the OPQ perpendicular to QR, it means that they form 90 degrees when they meet there. Yeah. So the first question, the symbol say that determine the length of PQ. Meaning this length there of PQ, leave your answer in squared form. So this thing, guys, is straightforward there. 2.1.1, what they need you to do there, they need you to apply distance equation there. This equation, whereby here it's x2 minus x1, y2 minus y1 plus. Do you see? So now let's focus on that line of PQ there. We are given the point of P, also we are given the point of Q. So this I will name it as point 1, this one I will name it as point 2 there. So now what I can do there, I can substitute now. So this is how you substitute there. Where there is x2, you'll put 6. And where there is x1, you put 1 there. And now where there is y2, you'll put 3. And now where there is y1, you'll put 0 there. Yeah. Do you see? Yeah. So now what you should do there, you can press all the thing there on your calculator. Meaning that thing there, when I press on the calculator, it is squared. And 6 minus this 2 and plus 3 minus 0. So this is the answer that I get there. And that they told you that leave your answer in squared form. Meaning you leave your answer like this. You can just say units there. This is how you solve the first question there, which is straightforward. Now they say determine the gradient of PQ. They need the gradient of that line. Do you see that line the way it is? It means that line there, it will have a what? A positive gradient there. Because you can see the shape the way it is there. So it means that you can just apply gradient equation PQ, which is y2 minus y1 divided by x2 minus x1 there. Whereby M, which is PQ, whereby you know that your point 1 is this one, which is x and y. Then your point 2 is that one, which is x and y, x and y. Then you can press that thing there on your calculator, meaning this thing that when I press it on a calculator, it will be 3 minus 0 divided by 6 minus 1, which is, I will get that fraction there like that. Or that answer, you can write it in decimal. It's up to you. Do you see? Yeah. But a key thing there, it's for you to notice that the line there, it is increasing there. Meaning that it has a positive gradient. Even you there, you are getting a positive gradient, as you can see there. Now, the next question, will say, now determine the coordinate of T. Where is T? T is this point there. So another thing, guys, that will guide you is for you to read that statement for this question. Determine the coordinate of T. It is good for you to read that statement. That thing symbol says that in the diagram below, PQR are the vertex of a triangle such that PQ, meaning PQ equal to what? QR there. Equal to QR there. And PQ perpendicular to QR there. T is a point on PQ such that T is the midpoint. Here they told you that T is a midpoint there. S is is the point of intersection of RQ and x-axis. V is a point on the x-axis such that QSV, it is equal to 121 degrees there. So a key thing there from that statement, it's for you to see that T is the midpoint of PQ there. This thing, it is the midpoint of PQ there. That is the key thing that you should understand about that point. And now for you now to get that point there, that coordinate of T, obvious, what you will do there is for you to apply what? A midpoint equation there. Since they told you that that thing there, it's a midpoint, so you can just apply your midpoint of saying midpoint of PQ, which is x2 plus x1 divided by 2 plus divided by 2 there. So now you can just substitute there. You can substitute plus there. Or before guys you substitute there, a key thing for you is to identify which one is your point 1. So P there, we say that this one is our point 1, and this one we say that one is point 2. So this is point 1 and this one is point 2 there. So there you can just substitute them, whereby where you see x2 you will put what? You will put 6, and where you see x1 you will put 1 there. Where you see y2 you will put 3, and where you see y1 you will put 0 there. And this thing, it's a midpoint of what? Of PQ, which is that midpoint there. It's a coordinate of T, by the way. So now you can use your calculator. When you press this thing on your calculator, you're supposed to get 40, and when you press this one it will be 3/2. Do you see? So now you can leave your answer like this, or say P, which is 4, and this one there, it will just be 1,5. Yeah. So it's up to you which method that you will leave. But if guys are dealing with the coordinate, it is better a coordinate to write it in what? In decimal form. A coordinate there. The reason why you write this thing in decimal form, it's because when you want to go and check on your Cartesian plane, you should be able there to identify that point as 1,5 there. Meaning that 1,5 is for the y value, which is here, and that 4 is for the x value, which is there. All that thing there should correspond with the Cartesian plane there. Do you see? Yeah. Then now, these question, all 1, 2, 3, they become kind of tricky, this one. Calculate the area of QTR. Let's check that QTR. So this is the triangle, that one, QTR. That one, it is the triangle